Hello class, welcome to this video on the 4.1, 4.2 practice. So wanted to go ahead and cover the practice problems as I usually do in case some of you guys are having a tough time with the concepts here. So let's go ahead and get started with the first question. Some of these questions, it's a mixture of 4.1 and 4.2 and it's not in any particular order. So I think the beginning stuff may be 4.2, but I think it's sort of kind of scrambled in with the practice. So looking at the first question, we have a triangle, and so this is a 4.2 type of question. And basically, so if you look at the diagram, you can see that the two angles F and E are equal or congruent, right? And so because they're congruent with this little symbol here, that should tell you that because they're congruent, that should tell you that these two sides are congruent. Remember that the side that is opposite of the angle is the angle that refers to. And so those two sides are opposite of those two angles. And since those two angles are the same, that implies that these two sides are the same. And so these two sides are congruent. So that means that DF, side DF is equal to side DE. And so a DE is 40 and DF is also 40. So this is technically true, and therefore this is not the right answer, right? So we're going to cross this out. So if we want to solve for x, we're going to take this and set that equal to 40. So 8x minus 24 is equal to 40. And so we'll add 24 to both sides to solve for x here. 8x equals 64. Then we got to divide by 8. So we know that 8 times 8 is 64. And so this is going to give us x equals 8. And so this is true, which means it's not the right answer because we're looking for incorrect. So if you plug in 8 into this bottom side, you're going to have 6 times 8 plus 10. It's going to be 6 times 8 is 48. 48 plus 10 is 58. And so that indicates that EF or FE is 58, which that is true. And so this cannot be correct. So I wanted to go through this entire process just to kind of eliminate those answers and to kind of show you how to solve for x and stuff like that. But we can clearly tell it's going to be B that's incorrect because DE is actually 40 and it's not 58. So you can easily have picked this answer. However, I wanted to, kind of show you the process of eliminating those other answers because I want you to see, how you would solve for x and stuff like that. So let's look at the next question. Which of the following statements is incorrect? So a triangle with 3 congruent sides is equiangular. So we know that a triangle with 3 congruent sides is an equilateral triangle. But we also know that an equilateral triangle has all the angles being the same as well. And to find the angle, you just take 180 degrees divided by 3, and then that's going to give you 60 degrees per angle. And so an equilateral triangle is also known as an equiangular triangle. So this is actually true, which means it's not the right answer because we're looking for the statements that are incorrect. Okay, so it's not A. The isosceles triangle theorem can be applied to equilateral triangles. So is that true? And the answer is yes, that is actually true. So if you have an isosceles triangle like this, right, that means that these two angles are equal. Well, this applies to an equilateral triangle as well. So if you have an equilateral triangle like this, well, these two sides are equal, but also the bottom side is also equal as well. But just kind of ignoring the bottom side for a second, well, you can say that these two angles opposite are equal to each other in the same way that it was for the isosceles. So it doesn't really matter if all 3 sides are equal, you could still use the same theorem. And so this is actually true. And so this cannot be the right answer. The measure of each angle in an equilateral triangle is 120. Well, we just said it's not 120, it's 60, right? So 60 3 times is going to give us 180. So this is actually incorrect. And so this is the right answer. All right, so the third question, in the figure shown, what is the measure of angle A? So we know that this is an isosceles triangle because those two sides are labeled congruent, and so remember that this side corresponds to this angle, and this side here, BA, corresponds to this angle, 57. And so we know that since the purple and the red sides are equal, that means that the red and the purple angles are also equal. Okay, so that means that this red angle here, angle B, is also 57. And that's because these two opposite sides are congruent. And so now we can figure out what angle A is, because we know that angles in a triangle add up to 180. So we're going to do 180 minus, and then we'll go ahead and add the 57 and 57 together, and then we'll subtract that from 180. So 57 plus 57 is 114. We'll subtract that from 180, and we get 66 degrees. Okay, so clearly it's going to be 66 degrees. Triangle ABC is an isosceles triangle. That is correct, with base angles B and C. This is your base. Your base is basically opposite of the apex. This is the apex or the vertex. Sometimes we call it the vertex, or sometimes we call it the apex. But this is the vertex. So yeah, this is called the vertex. And then if you were to extend, if you were to basically cut this like this, this is going to be your height. And if it crosses at a 90-degree angle, the opposite side to that vertex is what we call the base. Okay, so this is the base on the bottom, and so the base angles are both 57 degrees. So that's what this refers to, B and C. And those base angles are 57, and they add up to 180. So this is definitely correct. Okay, so question 4. We have, what are the measures of the angles in the triangle? So here we have another isosceles triangle because of these markings here, right? And because these two opposite sides are congruent, well, that means that because this is referring to this angle, and this is referring to this angle, and those angles are, those sides are the same, that means those opposite angles are also the same. And so that's saying that this angle is equal to that angle. And so we're going to set those equal to each other. And that's the equation that they want you to set up here. And so now we're going to go ahead and solve for x here. We'll subtract x on both sides. We got 3x minus 34. Then we'll add 34 to both sides. We get 51 equals 3x. And we can divide by 3. And so x is equal to 17. So now we know x is 17. If we plug that in for here, right? If we plug it in here, we get 17 plus 17 is 34. So we know that this angle is 34. And similarly, if we plug in 17 into this one, 4 times 17 minus 34, we'll also get 34. So we got 34 degrees for both of these angles. And then if we plug it in finally for this one, 6 times 17 plus 10, well, you're going to end up getting 112 degrees. So we got 34, 34, and 112. Okay, so this one, there was a typo in this question. So there's something missing in this question that I forgot to add in the picture, in the diagram. And so I just eliminated this question entirely. So if you redo the quiz, you're not going to see this question, okay? I could not find the diagram that I used this from. After I checked to see like what the error was, I could no longer find that picture. I don't know where I found it from, but I can no longer find it. So I'm not able to fix that question. So go ahead and cross that out. You can redo the quiz and get 100% because that won't be in there anymore. All right, so the sixth question, which is now going to be the fifth question in the new quiz. So select all the true statements given that triangle PQR is congruent to triangle STU. Okay, so we don't really need the diagram for this. All we really need is, the congruent statement is plenty. Okay, so we know that from this statement, we can write down tons of statements here. Well, we know that PQ is congruent to ST, or line segment PQ rather, is congruent to line segment ST. So that's one statement. We can also say that PR is congruent to SU. Okay, so as long as you use the correct letters in the right order, then it works, right? So there's a bunch of different statements here. So definitely the first one is true. So we'll go ahead and check that one. This one's true. PQ is equal to TU. So let's look at that statement to see if that's true. So PQ is actually equal to ST, not TU. So we can cross that out. And then QR is equal to SU. Is that true? QR is not SU, it's TU. So this is not right. And then angle P is congruent to angle S, right? If you look at the statement, we can see that angle P is congruent to angle S. Angle Q is congruent to angle T, and so on. So here, if we look at this, well, if angle P is congruent to angle S, that means that the measure of angle P is equal to the measure of angle S. So that's how that works. And so here we're saying the measure of angle P equals measure of angle U. That's incorrect, right? So that's not right. What about angle R? We haven't done that one yet. So R is congruent to, angle R is congruent to angle U. And so this means that the measure of angle R is congruent to the measure of angle U. So this works out. This is actually correct. So we can go ahead and check that. And the measure of angle Q is equal to the measure of angle T. That's actually true, right? If you look at the statement. So we have here measure of angle Q equals measure of angle T. That's true. And so yeah, so we have, looks like we have A, C, and F for the correct statements. That's it. So now for number 7, Janaya analyzes the quadrilateral shown below. What transformation could show PQRS is congruent to TUVW? So we have two quadrilaterals. Those quadrilaterals are shapes with 4 sides. So 2 shapes with 4 sides, basically. And we want to figure out, okay, well, how do I get from this one to this one, PQRS to TUVW? So let's look at the answer choices to see how we can do that. Remember that if you can find transformations such that you can find a transformation that makes one overlap with 2, well, then we say that those 2 figures are congruent, right? And so if we can find transformations that make this fit, then we can say that they're congruent. Okay, so this is what we want to show. All right, so let's look at the first transformation. This first transformation here is a translation. So this is translating it 3 to the left. You see that minus there? We're taking the x value and we're subtracting 3 from it. So if the x value were 5 and you did minus 3, well, then that's just going to become 2. So really, you're just shifting it left. Okay, so this means that you're shifting it left 3. And then this means that if you go to your table of transformations, well, then you'll see that, okay, well, this is actually a rotation. So this is actually a rotation. And it's a rotation. So if we look at the example and the things, I have to actually draw it out because, you know, I don't tend to memorize these things. So if we had the value 2, 1 here, and we rotated it, let's see here, -1, and let's say we have -1 and 2, right? -1 and 2. If we took that and we rotated it 90 degrees clockwise or counterclockwise, then we can get this. Or we can rotate it 270 degrees clockwise to get this answer. Okay, so basically this is a rotation 90 degrees counterclockwise. Okay, so that's from your cheat sheet, which, you know, I just did a diagram to help me remember. But so yeah, so those are my transformations. Either way, you don't really need to know the transformation name in order to be able to do this problem. I just wanted to make sure that I reviewed that with you. But all you really need to know is, okay, well, I'm subtracting 3 from the x. So if this is S, right, we know that S has to map to W, right? So whatever S is has to go to W. And the coordinates of S are 3 and 1, right? 3, 1. 3 in the x, 1 in the y. And so I'm going to subtract 3 from x, because that's what this is saying, right? Take x minus 3. So if I did that, and let me do that over here. So if I did that, this is 3, 1, and then I subtract 3 minus 3 is 0, right? So it's going to be 0 and 1. Okay, so now it's going to be at 0, 1. And then I'm going to take my 0, 1, and then I'm going to transform it. What am I going to do to it? I'm going to switch the x and the y according to this rule. And then I'm going to change the sign of my y. My y is 1. So my y is going to change from a positive 1 to a negative 1. Okay, so that's what I have. So now my new coordinate for s, which now becomes w, is negative, so s or w is negative 1, 0. Ooh, that looks pretty good because w is negative 1, 0 right here. So this looks good so far. So this might be it, but I'm going to go ahead and double check with the other answers just to be on the safe side, okay? So let's look at the second part B. xy transforms into x, y minus 3. So if this were to be 3, 1, and I transform it, well, x is going to be the same. X is going to be x, which is 3. And y is going to be minusing by 3. And y is 1. So we got to do 1 minus 3. 1 minus 3 is negative 2. So this is going to be negative 2. And then this new coordinate, 3, negative 2, has to transform according to this rule. We're going to do the same thing that we did in part A. We switch the numbers, and then we change the sign of the y. The y is negative 2. So if I switch it, it's not going to be positive 2 instead of negative 2, and then we'll have 3 for x. So this is incorrect, right? There's no way that w is going to have a coordinate of 2, 3. So this is incorrect. So if you were to work your way and do this for all the problems, you should end up getting the answer. You should end up getting the final answer. But let's go ahead and show you some more just so that you can get an idea of this. So this is 3, 1. It's also possible that it could be one of the other answers, so we want to make sure. So 3, 1 transforms into, so 3 minus, we got to do x minus 3. 3 minus 3 is 0, and y is going to be 1. Okay, so that looks fine. And so now 0, 1 is going to transform. So what's going to happen is we're going to put negatives, or we're going to change the sign and for x and y. So x here is 0, so it's just going to stay 0. Y is positive 1, so it's going to become negative 1. Okay, so w is going to be 0, negative 1. But we know that's not true because w is over here. So this is incorrect. And so on. So it looks like we definitely have a contender. It's going to be A. And I'll have you verify that it's not D. Okay, so which of the following statements is true? So we want to determine which triangle is congruent to the other one. So let's look at triangle JKL and MNO. So we have JKL. This is JKL here. And we're interested in seeing if it's congruent to MNO. So what we need to do is figure out, are the side lengths the same? And can we find a transformation such that if I transform this bottom one, it gives me the top one? It matches with the top one. And the answer is yes, there's a way to do this. There's multiple ways that you can actually do this. You could take this point and rotate this figure. You can actually rotate it. And so if I rotated this 180 degrees, well then this guy's gonna flip over, and so it's gonna look kind of like this. This is 1, 2, 3, 1, 2, 3. So it's gonna kind of go like this, right? If you flip that side over. All right, so similarly, if I rotate about K, if I rotate this side, right, and I flip it over, well, it's gonna go over here. And it's going to look something like this. And that's going to be J. Where is it going to be exactly? Well, it's going to be 1, 2, 3. 1, 2, 3, 4, 5, 6. So it's going to be 6 over 4, 4 over, and 6 in the y direction. So it's going to be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I was actually pretty close. It's like over here. So that's where it's going to rotate to. And then finally, this last one, so if I were to reflect this part, right, and I were to rotate it 180 degrees, I were to move this 180, right, then it's going to go like this, right? It's gonna finish off like that. Okay, so then if I did that, well, this clearly looks like it matches with that. And so 1, 2, 3, 1, 2, 3, 3, 4. I'm gonna double verify that. Yeah, so I think I did the J a little bit too high. Let me go back real quick. J was a little bit too much to the right because I think it was 1, 2, 3. 1, 2, 3. Okay, so J was a little bit too far. So I was a little bit too zealous with J. 1, 2, 3, 4, 5. So J is somewhere around here. Okay, and then this other one's gonna be like this. Okay, so now it looks more like the figure. Kinda. I think it might be around here somewhere. But yeah, it'll be something like that. And so basically they do look similar. And then if I take this and I move it over to the left and up, I will get the exact same figure. It will line up perfectly. Okay, so this is what I need. So because they line up perfectly, this looks like the right answer, but I'm gonna double check with B, C, and D, okay? Just to be on the safe side. So JKL and PQR. So JKL, PQR. Well, okay, let's see if this is true. If JKL is congruent to PK, well, that means that JK is congruent to line segment PK, right? Which means the lengths are the same. So if we look at JK, JK is this one. Is that side the same length as PQ? Well, let's see. It goes up 1, 2, 3, 4, 5, 6, right? And it goes 1, 2, 3. So 6 up, 3 over. 1, 2, 3, 4, 5, 6, and then it goes 1, 2, 3 over. So that looks fine. So far, that looks good. Now let's look at the other side. Let's look at KL. KL has to be congruent to QR, right? All right. So KL is this guy. That's 1, 2, 3 units across. And then that has to be congruent to QR. Oh, there's a problem here. 1, 2, 3, 4. That's actually 4, and this is 3. These do not match, right? So there's no way I can rotate this or do whatever to make those match. So this is incorrect. And similarly, you'll find that these other ones don't work out as well. So the congruent statement fails here, and therefore they can't be congruent. All right, so the answer is A. All right, so let's look at number 9. So given the measure of ABC is 114, what is BAD? So we know ABC, which is this whole thing, is 114. What is BAD? So BAD, this is the question mark that we're looking for. All right, so we know that this is an equilateral triangle, and because it's equilateral, that means these angles are all 60 apiece. So each of these angles is worth 60 degrees. Now, because these angles are 60 degrees, because this angle here on top is 60, well then I know that whatever this other side is, it has to add up to 114, right? Because the entire angle is 114. So I know that 60 plus the blue is going to give me 114. So 60 plus the blue, which we'll call X, is equal to 114. So then we'll just subtract 60 on both sides. So basically just do 114 minus 60, and that'll give you the blue. So let's see here. This is going to be 54 degrees. So 54 plus 60 is 114. So this angle here has to be 54 degrees. Okay, so we got that angle. Unfortunately, we weren't really looking for that angle. We were looking for BAD, right? So, however, we can find, with this top angle, we can find these other angles. Notice that these two sides are identical. So this side is congruent to this side. And therefore, because those opposite sides are congruent, that means that this red angle corresponds to this red side. So that red angle is actually congruent to this green angle, okay? So we know by the theorem for isosceles triangles that these two angles, the red and the green, are equal. And so let's call this, let's just call these angles x, because we don't know what they are. Or we used x already, so let's call them y. Let's call it a different variable. So y and y. Okay, so we got two variables. We know that they're the same because of the theorem. So they're both y, and then we got 54. Now we know that since this is a triangle, it has to add up to 180, right? So we got y plus the 54 has to add up to 180. And then we have 2y plus 54 equals 180. We'll subtract 54 on both sides. So we have 2y equals 180 minus 54 is 126. Then we can divide by 2 on both sides. So we got y equals 63. So 63 degrees is my angle, because this is y, but that's what we were looking for. So the measure of angle BAV is equal to 63. And you can just type in 63. You don't have to type in the degree symbol. Just 63 is fine. All right, question 10. So we got another isosceles. Let's see here. Yeah, we got another isosceles triangle. We can tell because both of these are C. So both of them are the same value. So these two are congruent. Therefore, this is isosceles. And this is my perpendicular bisector right here. So because the way I know it's a perpendicular bisector is 1, this is an isosceles triangle. 2, these two angles are the same, which means that this line segment cut this angle in half. And 2, this red line cut these two in half. And so those two are the same. And then this is a 90-degree angle. So this is a perpendicular bisector for sure. Okay, so now we know that each of these are 90 degrees on both sides, here and here. So it cuts it at a right angle. And then we're looking for DFE, right? So we're looking for this angle. That's the question mark. All right, so since we know that this is 90, they tell us that DFE is 70. So let's label that. Oops, that's the wrong one. Oh, okay, so we're not looking for that. I'm sorry. They said that DFE is 70. That's not the question mark. The question mark is DEG. So let's label that. DEG. So they're looking for this angle right here. That's the question mark. Okay. All right. So we know that this orange is 70, and we know that this is 90. And okay, well, because this is 70 and this is an isosceles triangle, that means that this opposite angle has to be also 70, because these two opposite sides are congruent, and therefore these two opposite angles are congruent. So that's true. So now because this is 70 and we have 90 here, 70 plus 90 plus question mark is going to be equal to 180. So let's call this question mark x. So we have x plus 70 plus 90 equals 180. And so 70 plus 90 is 160. And so x has to be 20. 20 plus 160 is 180. So this unknown is 20. So the measure of angle DEG is 20 degrees. And so you just type in the number. All right, question 11. We're wrapping up here. We got like a couple questions left. All right, so for number 11, find GJ. So we know this is GJ. And we know, how do we know that this is an isosceles triangle? First off, well, I know that this is an isosceles triangle because I know that these two angles are congruent. And because they're congruent, that means the sides opposite of them are also congruent. So these are congruent. So this is an isosceles triangle with these sides on the opposite being equal to each other. And so we know that these two sides are equal to each other. So we can solve that. So 6x plus 3 equals 45. Then we'll go ahead and subtract 3 on both sides. Do what we usually do to solve for x. Divide that by 6. So you get x equals 7. All right, so 42 divided by 6 is 7. So we got x. And remember, they're asking for gj, right? So we're going to plug 7 into gj, which is 4x plus 1. So we have 4 times x, which is 7, plus 1. So this will give us gj. 4 times 7 is 28. 28 plus 1 is 29. So this is 29. All right, we'll finish off with the last question. So a board game token is shown. Which is congruent to the token? So we have, so this is a congruence question, just like some of the other questions were congruence questions. So we got another congruent question. So this is 4.1. So basically what you got to figure out is which one of these can I transform? So which one of these is a transform version of this original board game token? So if you look at A, the only difference between A and this original is that the plus minus flipped over. It's not quite a reflection though, right? Because the plus sign reflected, but the dots did not reflect, right? Everything has to do the same thing in the figure. So there's something fishy about this one. There's no way that we can transform it with one transformation in order to get that. We rotate it, well, in this transformation has to be a rotation, a reflection, or a translation. There's no way that we can do either one of those three things in order to get A. What about B? Is there anything that we can do to get B? And the answer again is unfortunately no. If I rotate this token, there's no way that I'm going to get B. If I reflect this token, let's say I reflected it about here. Well, there's no way I'm going to get that token. I'm going to get a plus sign here, and then I'm going to get the dot like this, right? If I reflected it. So this is not going to be true. And there's no way I can translate it because as soon as I move this up, the plus sign has to move up as well. And so does the whole game board. So there's nothing that I can do because when you translate one thing, you have to translate everything. Okay, so it's not B. And then let's look at C. C looks very similar to what I just did. If I were to reflect this right here, then that would give me the plus sign here. And then that would give me, well, this dot is this far away, and then this dot is this far away. So yeah, it would actually look like this. So this looks true. If I were to reflect it about this vertical line, then it would kind of look like this and like this, right? So it's definitely not a vertical line. It's definitely a horizontal line. All right, so this looks good, but let's just finish out the last one. Yeah, this is definitely not right. There's no way that you can, this is kind of similar to this one. So no, this is not correct. All right, so this is what it means to be congruent. All right, guys, that is it for the video. I hope you found this useful. And as usual, I'll see you in the next one.